at translating a word problem into a two-variable solution. So the word problem we have here is if the cost to manufacture let me get my pen under control here. If the cost to manufacture, or to make, let's say make, a stapler. Why a stapler? Why not, right? Is $1.25. With a fixed cost of $110 per day. Write the total cost per day. Total cost per day. So what we have here is we have a couple of pieces of information. The fixed cost per day, $110 per day, is how much it costs just to be open, paying the base employees and paying the electric and utility bills. So no matter what, you make 0 staplers, you're still going to pay $110 per day. You make 1,000 staplers, you're still going to pay $110 today. That's what a fixed cost is. The $125, if the cost to make a stapler is $1.25, that's per stapler. So that's the cost of the labor and the material that goes into each stapler. So the total cost is going to be a combination of these costs. And this 110 per day isn't going to change because we're looking at, let me change my color though. The 110 per day is fixed, right? There's no multiplier. So we know that's going to be down here somewhere like this, just nice and fixed, $110. But each stapler is going to cost $1.25. So we'll make S the number of staplers, we're producing. Staplers. So 125 times S. Give that S a little hook. So if I multiply $1.25 per every stapler I made, plus the 110 fixed day cost, I get my total cost. And so we'll say C equals total cost per day. And we satisfied the equation. And now we have a linear equation. We have two variables and a constant. And so we have a linear equation that we can use to describe how much it costs to make a stapler per day. But the key is we have a cost per stapler, which is $1.25, and a fixed cost per day, which is $110. The total cost is the combination of those two things. This is a common type of problem, is a fixed thing, which our fixed thing is the 110 here, which is the C variable from our linear equation, and then in two other variables, in this case total cost and the number of staplers we're making. And so you got to get used to combining these things with two variables. What this lets us do is answer the questions that usually come next after this. So we're going to be looking, I'll move my equation up to the top of the screen here, rewrite it. C equals $1.25 per stapler, S with the hook, plus 110 per day. So we can say, what is the cost to make 500 staplers? So if I make 500 staplers, S equals 500. So C equals 1.25 times 500 plus 110. And that's going to give me, let's see, 5 times 12, 6. So get my calculator out here. And so we get, pull it up, total of $735 to make 500 staplers. And so this is what these equations let us do. They let us predict overall values and costs based on the things we're making. You can also do the opposite. If I had, in one day, the ability to spend $1,100 to spend, how many staplers can I make? How many staplers can I make with $1,110? Well, this goes in place of C, 110, equals 1.25 times S, which is what we're solving for now, plus 110. I've just switched variables here. I know C now, but I don't know S. And so I'm solving for S. And subtract 110 from each side. So 1,000 equals 1.25 S. I look like a 5. Or S equals 800. So I can make 800 staplers for $1,010. And this is where the usefulness of two variable equations come from, is you can work from either side of a problem. You can work for how much money you have to invest in this case, to how many staplers you get, to how many staplers you want to produce, and what that's going to cost you. And we'll see in the homework different parts on equations where we use two variables to make different predictions.